All right, this is lesson chapter 3 still, but it's the second part of chapter 3. This is the day 5 notes. We're headed to solving absolute value inequalities, but first we have to learn about absolute value equations. So this lesson is about absolute value equations. All right, so what absolute value is it is the distance from zero, right? Distance from zero. So there's actually two ways. If you're on a number line and you want to move from zero, there's two ways you could go. You can go to the right or you can go to the left. So to get rid of an absolute value bar here, inside we have an A. We'd solve that for positive 2 on the other side, and we'd solve it for negative 2. And those two are actually already solved, so that is done. Right? So because this is saying the absolute value of A means that I want to go 2 units away from 0. Well, if I go 2 units away from 0 to the right, I'm at 2, which is why one of my answers is 2. And if I go 2 units to the left, then my other answer would be negative 2. So to get rid of an absolute value bar, you solve for both positive and for negative. So like on this next one, to get rid of these absolute value bars, to cancel those out, you go positive and negative on the other side. So you go negative 6n equals positive 36, and negative 6n equals negative 36. So then to solve, we divide by negative 6 to find out that the first answer would be negative 6. And then when we divide negative 36 by negative 6, we find the other answer to be positive 6. Now when you go to type these into Math Excel, they're going to have you just separate them with a comma. So you type it in n equals negative 6, comma 6. That's how they have you type it in Math Excel when you go to do your work. All right, so let's move on. Ooh, what's happening over there on that side of the board? So let's see here on number 3, we have absolute value bars. So to get rid of them, you would solve the positive and negative. So we have 10a equals positive 30, and then we'll do 10a equals negative 30. So to get rid of a multiply by 10, we divide by 10. So 30 divided by 10 gives us our first answer of 3. And then negative 30 divided by 10 gives us our second answer of negative 3. Now don't think that your answers are always going to be the same number, just opposite signs, because that only happens here on these easier problems at the very beginning. So on number 4, to get rid of those absolute value bars, I'll go positive and negative. So I have 2p equals 6, and then 2p equals negative 6. So when I divide by 2, 6 divided by 2 is 3, and negative 6 divided by 2 is negative 3. Again, just hang in there. It's not always just going to be the same number, but a different sign. So on this next one, I can see I have my absolute value that's equal to 11. So I'm going to solve for positive 11 and negative 11. So I have n plus 1 equals positive 11, and then n plus 1 equals negative 11. So when I subtract 1, 11 minus 1 gives me an answer of 10. And then negative 11 minus 1 gives me an answer of negative 12. Number 6, my absolute value is equal to 90. So I'm going to do negative 10n plus 10 equals 90. And negative 10n plus 10 equals negative 90. So you can see same concept, but now here we have a 2-step equation instead of all the ones up to this point having 1-step equation. So to solve, to get rid of a plus 10, I would subtract 10. So negative 10n equals 90 minus 10 is 80. And then 80 divided by negative 10 gives me n is negative 8. And then on the other one, to get rid of the plus 10, I still subtract 10. So I have negative 10n. Negative 90 minus 10 is negative 100. Negative 100 divided by negative 10 gives me n is 10. All right, so let's go to the other side. And now you can see, first of all, the absolute value is not alone. right? You make it and you solve for the positive and negative once the absolute value is alone. Here, this absolute value is not alone yet because of this plus 9. So the first thing you're going to have to do is get that absolute value alone. So to get rid of a plus 9, we would subtract 9 on both sides. So now we have the absolute value of 2n minus 6 equals 6. So now that the absolute value is alone on one of the sides, you have the absolute value by itself that equals a number. Now you would go positive, negative. So now we do 2n minus 6 equals 6, and then 2n minus 6 equals negative 6. So before you can break it apart to positive and negative, you have to have the absolute value alone. So now to solve, to get rid of the minus 6, we add 6. So we're at 2n equals 6 plus 6 is 12. 12 divided by 2 gives us 6. And then on the other one, same steps, but when we add 6 to negative 6, we get 2n equals 0, and then 0 divided by 2 gives us 0. Same thing on number 8. Our absolute value is not alone, right? He is not alone because he's being divided by 10. So to get rid of that divide by 10, I would multiply both sides by 10. So then the multiply by 10 cancels out the divide by 10. I have the absolute value of n plus 1 equals 10 times 2 is 20. Now that my absolute value is alone, I can break it to positive and negative. So I do n plus 1 equals positive 20, and n plus 1 equals negative 20. So to move a plus 1, I would subtract 1. So 20 minus 1 is 19 for my first answer. And then when I subtract 1 from negative 20, my second answer is negative 21. So before you can break it into two problems of plus and minus, you have to make sure that you get that absolute value alone. So like on number 9, I can see that absolute value is not alone. Not alone because of that plus 10. So to move a plus 10, I would subtract 10 on both sides. So then I'm at the absolute value of 2x minus 2 equals 20 minus 10 is 10. Now that the absolute value is alone, I break it apart. 2x minus 2 equals positive 10, and 2x minus 2 equals negative 10. Two-step equations. To get rid of a minus 2, we add 2. So we're at 2x equals 10 plus 2 is 12. To get rid of the multiply by 2, we divide by 2. So x equals 12 divided by 2 is 6. For the negative one, when we add 2 to negative 10, we get 2x equals negative 10 plus 2 is negative 8. And negative 8 divided by 2 is negative 4. Number 10, there's two things keeping the absolute value from being alone. So just like you would do if this problem would be like 3 plus 4x equals 35, you're going to subtract 3 and then divide by 4. What's keeping your absolute value from being alone, first of all, is this positive 3. So to move him, I would subtract 3. So then I'm at 4 times the absolute value of 5 minus k equals 32. Absolute value is not alone yet because he's being multiplied by 4. So the opposite of multiply by 4 would be to divide by 4. So now we're at the absolute value of 5 minus k equals 32 divided by 4 is 8. Now that your absolute value is alone, you would go positive and negative. So you have 5 minus k equals 8, and 5 minus k equals negative 8. So to get rid of plus 5, you would subtract 5. So you have negative k, that negative is still in front of k. 8 minus 5 is 3. Remember, that's a negative 1 in front of k, so I divide by negative 1 to get my first answer of negative 3. Second part, to get rid of a positive 5 and subtract 5. So again, I have negative k, now equal to negative 8 minus 5 is negative 13. And negative 13 divided by negative 1 is positive 13. So those are absolute value equations, the distance from 0. So you always have to solve for the positive and negative. You have to get the absolute value alone first before you break it into the positive and negative to solve.